All of these, well, with the exception of that one and some of the other notations, but most of these are showing the 45s, or at least something we recognize, right? This one's a little unique. So, what's the 8 on? Leg. So x is 8 root 2. Good. And it didn't ask for this one over here, but it's the same as which one? As the other leg. Yeah, so 8. Okay, and then here, it's again a 45. We know this is 45. Why? Yeah, 180 in a triangle. So, what is the 14? The leg. So y is 14 root 2, and x is just 14. Okay, so this one shows some notation we saw yesterday where it's showing that it's an isosceles. Isosceles right triangle. So even though it doesn't say 45, we know it is 1. So what is x? Good. What kind of shape is that, speaking of? Square, yeah. Alright, let's do this. I guess we'll go to this one next. Nothing in there about the angles. So how do you know it's 45, 45, 90? Well, but that just tells us it's a 90. I mean, these could still be like 50 and 40, or whatever other combination adds up to 90. So how do we know that it is for sure a 45, 45, 90? It is, that's exactly right. Since both of these are x, even though they don't have a number, it's telling us that, like Bailey said, that they're congruent, which makes this, you guys remember I drew this yesterday, where the angles opposite of the congruent sides are also congruent, which means they're 45. Okay, so this time we were given the hypotenuse. How do we go back to the leg? Yeah. All right, next one, same idea. What's x? 2. Good. And then this one, same notation as that first one, but back to the leg again. Okay. Anybody try this one? Well, do your best to draw a square. It says the perimeter is 48. What is true about all the sides in a square? Yeah, so they're all how long? Yeah. So 48 means distance around the whole thing. So we know each one is 12. Let's call it S for side length. Okay, and then it says find the length of the diagonal. Remember the diagonals? Okay. Could you use Pythagorean theorem? Well, remember we have a 90 right here because we were told it's a square. Could you use the Pythagorean theorem? Yeah. But you don't have to, but you could. So I want you to just kind of think to yourself, would you rather solve this, or would you rather just go, hey, that's a leg, so the diagonal is what? 12 root 2. Which one would you rather do? Yeah, because this one you're going to have, let's kind of demonstrate actually. Okay, and I wouldn't want you to leave it as square root of 288. I would want you to simplify that to 12 root 2. So do you see how much more work that can be? Sometimes that's what you do. Like, you know, if this didn't happen to be a 45, 45, 90, then you'd have to use the Pythagorean theorem. But in those cases when it is, boy, it's nice to use the special right triangles. So how'd that go? Okay. Okay. Yesterday we worked on. Did we start checking? Yeah, that's right. Let me
Check.
make this so you can see it. Yeah, that's what we did, huh? So you said we checked. Do you guys see a scroll bar on the bottom?
No.
Oh yeah, there it is. Oh. If you ever become a software engineer, please don't make your scroll bar the same color as the background. It's so hard to see. Alright, so there's number 5. How'd that go?
Well.
Okay. By the way, this is that process called rationalizing the denominator that I have mentioned but not shown you.
So I was right.
So if you did 10 divided by root 2, that's where we are. Okay. Now you're going to see that as we go through. So let me know if I need to explain what you should have seen.
If you like solve those, when you got a different answer, is it still right?
I don't know. Did you get 10 divided by root 2?
Yeah, I did that, and then I did the 5 root 2, and I got 7.07.
Yeah. You don't need to do that for these.
So you can just leave it like that?
Alright, let's see. From there, how about 10, 11, 13 we actually did in class the other day. Do you guys remember doing that one? I skipped showing you 7. Yeah, I did. There's 7. Remember, root 2 squared is just 2. The squared cancels the root. Now can I go down? Okay. That was all on that page. I don't think this has the other page on it, so let me go pull that up. True. Let me just tell you what it was.
You get a laser pointer. Then you could be at your desk and just pointing out there.
But I don't want to be that kind of guy.
Or you could just
Work here, please. Wouldn't you hate it? I guess my wife had a teacher in high school that had like super thick glasses and he talked like that. I don't know, hopefully I don't sound like that. At least not every day.
I think that the voice for those language is like spoken.
Number 18, x should be 12 divided by root 2. Good? Alright, so with today's warm-up, what was that, like 7 problems and these, do you feel like you're ready to switch gears to 3069? Sure? Alright, well grab your notes then. Set that aside. There's 30, 60, 90 problems on there that we'll come back to, so keep that handy. Why is it 30, 60, 90? Has to add up to 180, right? Okay.
You want a flat cup?
Not really. Thanks.
Then you don't have to.
What?
Then you don't have to use that cup.
I think it's probably worth showing you where these relationships come from, and then we'll write the relationships on here. What do you guys think? Does it help to know? Kind of like we did? Okay. Okay, next question. Eventually you just need to know the relationships like we did with 45s. So root 2 was that one, right? Times root 2 or divided by root 2. There's more going on with these. So I'm thinking we just put that here and I show you where it comes from on a different, okay. By the way, that's called a derivation. So, if we start with an equilateral triangle, what does that mean? I don't like this one because it doesn't look like it actually. What was it?
All sides. Or
Does that kind of look like all sides are equal?
Yeah.
Okay.
kind of, yeah.
Actually, hold on. This has
You
the
have
only
to-
triangle tool that it has, I think, is
I don't think it's working.
yeah, I can make that. Perfect. Okay. Anyway, what are the measures of all three angles if it's an equilateral triangle? Okay, remember they're all equal too, so we also called it an equiangular one. So they're all 60. Okay. Next thing, if we draw an altitude. It's no very good one. Remember, an altitude means it has to be perpendicular to the opposite side. So that makes this a 90. Okay? What did it do to this top angle? Yeah, so it bisected, split it in half. Good job using bisected. So what is the measure now of this angle, or either one of them actually? Okay, so this is how we're thinking through the 30, 60, 90 triangle, okay, so far. Next, if we call each side length 1, remember how we did that on the 45? We just drew a 45 triangle and called one of the legs 1, okay? So we're doing the same thing here. How long is this piece if we do that? If we call all side lengths 1, how long is this piece? Yeah, it's a half. Okay? So that's our first relationship in a 30, 60, 90. The short side, we'll call it, it's the side opposite of the 30, is 1/2 of the hypotenuse. Which is nice, right? There's no square root there. It's just 1/2 of the hypotenuse. So the next thing it would be to get this relationship. How could we get that from what we know so far? And if it helps, we can pull this left half of the triangle off. If you were just given that as a problem to do, what would you do? Yeah, let's do the Pythagorean theorem, okay? So we're going to say, I'll write it first. A squared plus b squared equals c squared. Remember, c is always going to be the hypotenuse. So this is 1/2 squared plus, can we call this x for a minute? Okay. And then 1, hypotenuse is just 1 squared, which is 1. Okay. 1/2 squared means 1/2 times a half, which is what? A fourth.
1/4.
A fourth, yep. 1 squared is 1. Okay, what do we need to do next to solve for x? We need to get it by itself. Yep. Good job. What is 1 minus 1/4? 3/4. Good. How do we get rid of squared? Okay. And then just as a reminder, square rooting a fraction, you can split it and square root the top and bottom separately. Okay? So how big is x? Well, square root of 4 is 2. Square root of 3 we're not going to change. We're going to leave it that way. Okay? So this is kind of why these are a little bit harder, because now the medium side is the square root of 3/2. That's its relationship to the other two sides. Okay? So square root of 3, why don't you grab your calculator? and just square root 3, and then divide it by 2, and you should get like 0.6 something. 0.86, thanks. Yeah, that's right. Okay, so think about what that's telling us. The short side is half of the longest side, and the medium is like almost as big, right? 0.86 or 86% of the size. Okay? We're still going to use it the same way as we did with the 45s. Like if I give you this one, you can split it in half to get this one, and multiply it by root 3 over 2 to get this one, and vice versa, okay? Divide, divide. So there's more going on, but it's the same kind of concept. Does everybody understand kind of where it came from? It's just setting the side lengths equal to 1, and then doing, like splitting that one in half, that was easy, and then doing the Pythagorean theorem to get the third side, okay? All right, so let's put this, try to do another map. In terms of the verbal description, because there's 3 relationships, well, technically there's 3, we'll have to not get carried away writing a whole bunch down, because I think that would just make it more confusing. First thing I want you to write is what that picture just showed. Okay? But make sure you put your 90 in to know which one is the hypotenuse. My suggestion for these, how do I want to say this? I think students usually do better with it if they find the small side first, the short side, whichever one you're given. Like if you're given that one, great, it's easy. If you're given the other 2, I would go to it and then to the third side, okay? So I think it's not a requirement. If you feel comfortable using this, then you're good. For example, how many times bigger is the medium side than the short side? Like if I knew this, don't write this, just think with me. If I knew this side was 5, how would I get to that one? Like, do you see the relationship at all? In other words, what did you do to this to get this? That's the relationship. Like, what do we do right here? So do you see how I already have a 2 in the denominator? So I just need to multiply by root 3, right? And then it becomes that. So in other words, this short side needs to be multiplied by root 3 to get the medium side, okay? Let's put that in here in a little bit more obvious way, like we did yesterday. Okay, so find the short side first. Okay, so you're going to have to help me communicate how to you in terms of wording, because I didn't do it right the first time. Like, you didn't like the way I did it the other day, so let's try to do it better. So if I am, here's what we need to write down. If you're given the hypotenuse, how do you get the short side? If you're given the leg, the long leg, the medium side, how do you get the short side? So how can we word that to help you? Do you like the if you're given, or do you like to find? if you're given, okay. Don't write this yet, because again, I want to word it the best way for you. To get the short side, you have to just divide the hypotenuse by 2, or times a half. First of all, do you like divide by 2 or times a half better? Divide by 2? Okay. Do you want to say short side equals hypotenuse divided by 2? Does that work? All right, and then do you want to call this the long leg or the medium side? Which one are you more familiar with? Okay. And we might have to come back and adjust this. We'll see how it works after we try it a few times. So this one is where you're going to divide by a radical, a square root. Okay, and I think this is what we can do to shorten, because we could write this out where there's a whole bunch of different directions, and I think it would be confusing. So on your picture, just do this. Let's see if this works. Again, we can come back and edit as we need to. Okay? So this is short times 2 and short times root 3. So as long as you know the short side, you can just come back in and look at your picture, and then the long side is times 2, like the hypotenuse is times 2, the medium side is times root 3. Okay? And you're only ever going to have to do one of these. You're not going to ever have to do both. Well, you're not going to have to do all of this, let me say it that way, all at once, right? Because think about it. If I give you the hypotenuse, you're going to find the short side and then only multiply by root 3 because you know the hypotenuse already. Okay? If I give you the long, I'm used to calling it long leg. If I give you the medium side, you're going to find the short side and multiply it by 2 to get the other side. So you're never going to have to do all 4 of these things we just wrote all on one problem. Okay? It will only ever be 2 of them. So maybe it's these 2 red arrows if I give you the short, or it's find the short and then the medium, or it's find the short and then the long. Okay? But you're never going to have to do all 4 at once. So let's try it a few times. Are we good on the... Okay. Again, we can edit if we need to. Maybe let's start off a little bit before that. Okay. So I want you to find the other 2 sides each time, and I'm just going to change where I write it. So we're going to call this 12. Okay? So don't shout it out. Okay, how long is this side? 6. That's the short side. So it's just half, or divided by 2, okay? Now we have the short side, we need the medium. So let me know when you're ready for that one. Okay, what'd you get? 6 root 3. Okay? So from short, it's nice because it's just multiplies either way. Okay? So what I meant for you. Okay, what's that one? 4, right? So I gave you the short this time, so that becomes times 2. And then what's this one? 2 root 3. Okay? Alright, let's try another one. Now I'm kind of switching the game on you a little. What should you find? If I want this one, what should you find first? Go to the short one first, okay? So what is the short one? Yeah, no, I know my picture is not great looking, but note that that's the right angle. So this is what? 15 over root 3. Okay? So we divide 15 by root 3 to get from medium to short. And then short to hypotenuse is what? Times 2. So how does that look? Well, it's 15 times 2 divided by root 3, but what is 15 times 2? Yeah. So that's usually the hardest version when you're given the medium and you have to go around and find the others. Okay? Notice, actually I don't want to say that right now. I think we saw the next slide, I think, has something like this. It's probably a different side length, but that's okay. Okay? There's your right angle. I forgot to put that on. So go to the short first. Hypotenuse to short, what do we do? Divide by 2. Okay, so what's the short? Everybody say it. 6 root 3. Right? We can't divide the square root. We just divide the number up front. So 12 divided by 2. Okay, and then we go to the medium side. How do we go from short to medium? Times root 3. So this is one of those kind where we get 2 of these root 3s. It cancels the square root. So what is the square root of? It will be 18 because this is root 3 squared, which cancels the square root. So this is 6 times 3, so 18. Okay. And by the way, if you just type it in, it'll do that for you. If we wrote, I think you should know that square root squared is, it cancels, right? But if you type 6 root 3, and then don't forget to arrow out of there, and then root 3, it tells you, like it will do that, but just also know. Okay, so what do you think? Is your note working? Are those helping? Okay. Let's see what this one was. All right, which side of the triangle is the 9 root 3?
That is the
Side.
side.
I've heard medium and long. Anybody want to say short? Okay, it is the medium. How do we know? Because you can't really tell in the triangle picture, right? So remember, you always look opposite. Do you see how 60 is looking opposite of that side? So 60 is the medium angle, so the medium side is opposite of the medium angle. Okay? So I'm just going to write X and Y so I can. Which one should you find first? Y. Yes, Y. How come? Yeah, it's the short side. I think it's just easier to go that way. So how do you get from medium side to short side? Divide by root 3. So 9 root 3 divided by root 3 gives you 9. Okay, so what is the hypotenuse then? Times 2, which is 18. Okay? Real quick, I'll put this back, but if that's all I gave you, could you solve this with the Pythagorean theorem? How come? Yeah.
There's too many variables we don't know about.
Yeah, there's only one side length given, and so if we left x and y in there, it would be x squared equals 9 root 3 squared plus y squared, and that's, like he said, too many variables, right? And since it's not an equilateral, I can't just copy that over here. So with 30, 60, 90 triangles especially, sometimes you have to use this relationship and not Pythagorean theorem. Okay. How about we start on that sheet with this second table, the 30, 60, 91 in the back. So it's like the one that we did with the 45s, only a different triangle. And how about we just work on it and then check it, and then if that goes well, you can do the other problems on that page. I'm going to make sure I have it pulled up. Kind of basically what we were just doing on where I was drawing it. So if P is 5, which side, actually it probably would be helpful before we do that, P, Q, and R, and just label them in here. So what is P, the name of the side P? Yeah. Okay, and then Q, and then R is hypotenuse. Okay, so if the short side is 5, let's jump to hypotenuse. What is it? It's 5 times 2. Okay, so this is 10. And then how about medium? 5 root 3. Good? Okay. If we're given the medium, how do we get short? Let's start there. Divide by root 3, which just takes it off in this case. So it's 3. Then go short to hypotenuse. What do you get? It's just double. Yep, so 6. Okay. Now we're given the hypotenuse. Let's go short first. For given hypotenuse, what's the short side? 10. And then short to medium? 10 root 3. Okay, back to the short side again. How do we go? I don't care which one we do first this time, but short to medium. But let's write it out. This is 2 root 3, the short side, times what? Times root 3 to get the medium side. What is root 3 times root 3? Good. So this is really 2 times 3, which is 6. Okay, how about short to hypotenuse?
Times
Just 2. Just times 2. So 2 times 2 root 3. What do you do with those 2's? Yeah, just multiply them. So this is 4 root 3. Everybody good? Okay, hypotenuse to short. We always go to the short side. We don't have to. It's just a suggestion. But long to short. What do we do? Divide by? Long to short. All right. This given hypotenuse short. Okay. We can edit that if it feels like it's not working. Okay, so we're just dividing the outside 6. You can't divide inside of the radical, just the outside 6. Okay, now how do we go short to medium? Times root 3. Okay, this is going to involve a little bit. Let me write that out. Actually, the other way. So we're doing 3 root 6 times root 3. Everybody good? Why we're doing that? Short to medium is times root 3. Because these are both square roots, we can multiply inside as long as they're both square roots, which these will always be. So this would be 3 root what? 18. But we can simplify the 18. What can we split 18 into that we can square root? 9 and 2. And what's the square root of 9? 3. So 3 times 3 root 2. So this whole thing becomes 9 root 2. Okay? How'd that go? Okay enough to start the other problem? Okay. Well, go to the other side. The rest of these should be 3069s. 15 has both. So you'll have to switch back over to 45 for the top part. But let's just take some time to try this out. Sound good? How are your goldfish? Good choice.